We're going to cover 12.2, 12.3 today. Our objective is to determine the surface area of prisms, cylinders, pyramids, and cones. Some vocabulary. A prism is a polyhedron with two congruent faces called its bases that lie in parallel planes. So here's an octagonal prism. We call its faces are the top and the bottom because they're parallel and they're congruent. All right? And that's how I'm going to name the prism, by what its base is. The lateral faces of the prism are the parallelograms formed by connecting the corresponding vertices of the bases. Okay, so the sides, the part that are not the bases, that connects the bases, that is your lateral faces. Lateral means side. Sometimes you're asked to find the lateral surface area. So you just find the area of the sides and not the bases if they ask for that. The lateral edges of a prism are the segments connecting the corresponding vertices of the bases. So these vertical lines in this picture are the lateral edges. Remember, again, just think, when you think of lateral, think of sides. Any questions? The surface area of a polyhedron is the sum of its faces. So here I would add 2 pentagons and 5 rectangles to find the area of the polyhedron, surface area of the polyhedron. The lateral area of a polyhedron is the sum of the area of its lateral faces. So you're just adding this area of the sides if you're doing the lateral area. Now when I say sides, the sides possibly, if this were turned on end, right, and the pentagons were this way, your sides could be, on the top and on the bottom. They're still considered sides or lateral sides because they're between the two parallel bases. A net is a two-dimensional representation of the faces of a polyhedron. The cutout activity you guys did last time, you cut out nets. Those were the two-dimensional cutout of the shape was a lot different than when you folded it and made 3 dimensions. Okay, the two-dimensional cutout is the net. Right prisms. Right prisms. Each lateral edge is perpendicular to the base in a right prism. Each lateral edge is perpendicular to both bases. An oblique prism is a prism with lateral edges that are not perpendicular bases. So you can see we've got the bases here are pentagons, but the lateral edges are not, they don't make a 90 degree. Here, they make a 90 degree angle in a right prism. Here, they don't. Right? So that'd be an oblique. If it's slanted or tilted, then it's an oblique prism. Everybody understand the difference? All right. Find the surface area of a rectangular prism with a height of 2, length of 5, and width of 6. So if we drew that, okay, we have, here's our length, and then the width was 2, and the distance back was, well, they called the length 5. The length was 5, the width was 6, the height was 2. So you can kind of think of the area as a net. I don't expect you to draw this every time you find the area, but this is just breaking it down. If I unfolded this box, the outside sides, I would have a shape with these 2 larger rectangles, and we have these 2 smaller rectangles and these 2. And then I would find the dimensions and we know how to find area of rectangles, length times width, and we could find the dimensions of the shape. Okay, but like I said, I'm not expecting you to find the net every time. So we've got, if it's sum of the faces, we've got the left and right faces are 6 by 2. All right, so that their area is 12. The front and back faces, are 5 by 2, so their area is 10, and the top and bottom are 30. Right? So then I'm going to multiply each one of those by 2. Okay? The 12 times 2, 10 times 2, and 30 times 2, and I get 104. Now, how I'm recommending you approach this is, I'm going to make sure everybody's got this written down. All right, so going back to the original figure, right? You can do it based on this picture right here. With this picture, right, you can look at it and you say, okay, the bottom, what's the bottom? The bottom and the top are 5 by 6, so it would be 2 of those, 2 times 5 times 6. Plus, then you look, okay, the right side is 6 by 2, so the left is the same. So it's 2 times 6 times 2. And then the front and the back. The front is 5 wide and 2 high. So it's going to be 2 times 5 times 2. That's how I would approach it. I wouldn't unfold it as a net and calculate it that way. I would just look at the picture and make sure you're covering every side. Okay, any questions there? All right. Surface area of a right prism. Okay. When you have a right prism, well, another way to think of it is 2 times the basis plus the perimeter times the height. So how this works is, so let's take an example. So we have this pentagon, right? It's a pentagonal prism, and it's the top and the bottom are regular. It's a regular pentagon, the top and the bottom. All right, so if we do 2 times the base, all right, we would have, first of all, what do I need to find the area of the bases? What do I need to find? I can't find it yet. What do I need to do? I need to calculate what? We need the apothem, right? Find the area of the pentagon. We don't have, so let's find the apothem. So we take this triangle, since it's a pentagon. Okay, so that means that the angle here would be 180 divided by, or 360 divided by 5. So it's going to be 72. So if this is 72, then half of that would be 36, right? And we have the hypotenuse is 6. So what could I do to find, we need to find the apothem, this length right here. What would I do? Which trig function would I use? We have to find the adjacent. We know the hypotenuse. Which trig function is that? Aaron? Cosine. Yep. Cosine. So we do cosine of 36 equals the adjacent x over hypotenuse 6. So x equals 6 times the cosine of 36. Somebody calculate that for me. Six times the cosine of 36. What'd you get? 4.85? Okay, so the apothem equals 4.85. All right. So, now, I'm going to clear this out, and we have to, let's do the 2b times plus a perimeter times the height. Okay, so we have 2 times 1/2 ASN plus the perimeter, which is going to be the number of sides. To find the perimeter of the base, we take the number of sides times the side length. So let's take n times s, and then the height, and then times the height. Right? So we have 2 times 1/2. The apothem is, we said it was 4.85. 4.85 times the side length is 7.05, and then the number of sides is 5. Okay, plus, then we take the number of sides again, 5 times the side length, 7.05 times the height, 9. Everybody understand what I plugged in there? Any questions on that? Right, got it? Okay, so what, somebody, did you calculate it, Kennedy? What's the answer? 488.2 feet. And don't forget to square your units. 482 feet squared. So you see the perimeter times the height, the same thing as adding these 5 sides together, right? It's just a quicker way. Because, you know, if you took one of these sides, if you'd have 7.05 times 9, you'd get that. But since there's 5 of them, you'd multiply them by 5 anyways. So if you do the perimeter, okay, the 5 sides times the 7.0 times 9, you do it all in one step. So it's just perimeter times height is this just shortening, adding up all the faces. Okay, they rounded it a little bit differently than we did, but okay. Height of a cylinder. All right, to find the height of the cylinder. You're wrapping a stack of 20 CDs using shrink wrap. Each disc is cylindrical with a height of 1.2 millimeters and a radius of 60 millimeters. what is the minimum amount of shrink wrap needed to cover the 20 discs. So they're wanting the surface area of the cylinder. So that the height of the stack would be 20 times the thickness of a disc. 20 times 1.2, this is 24. The radius is 60 millimeters. So the minimum amount of shrink wrap would equal to the surface area of the stacked discs. So we need to know how to calculate that. All right. So the surface area of a cylinder is going to be 2 pi r squared, because the top, if we consider a cylinder, we've got two sides, two bases, the top and the bottom. That's your 2 pi r squared, right? So it's 2 pi r squared, and then the side part of the cylinder, you got to think of it like this, okay? If we cut down the one side and then folded it, we would have a rectangle, right? And that rectangle, the length, this length on the rectangle would be the same as the circumference of the circle, right? It's just unfolded, and that's 2 pi r. Its circumference is 2 pi r, and then h is the height, right? So that's how we get this area formula for a cylinder. Make sure you highlight it in the notes. They would just jumped right into an example without defining that formula. But that, make sure you mark that as the area of a cylinder. So if we plug into that formula, we would have 2 pi, the radius is 60 squared, plus 2 pi, the radius is 60, and the height is 24. That should give us our answer. So calculate that, plug in, calculate, you should get your answer. Okay, so the answer should have been, plug in and calculate 31,667. And that would be millimeters squared. Millimeters squared. Okay, so then here's the formula for surface area of a cylinder: 2 pi r squared plus 2 pi r h. So this chapter will be the same thing. We'll give you, on the quizzes and tests, we will give you these formulas, but when you take the test, there'll be a memorization part where you have to do the formulas from memory, and then we'll give you the rest of the test, and you'll have the formulas to use. Okay, so you should try to memorize these. Okay, so here we have the height of a right cylinder is shown. Has a surface area of 157.08 square meters. All right, so we have, we multiply all this out, we get, so we have the area of a cylinder equals 2 pi r squared plus 2 pi RH. So that's going to be equal to 2 pi, the radius is 2.5 squared plus 2 pi 2.5 times h, right? And the area they gave us, I should set that equal to 157. That equals 157. Let's put it at the other end. That equals 157.08. So when we solve for h, we take 157.08 and we would subtract this minus 2 pi 2.5 squared, and that's going to equal, okay, it equals this, but we're going to go ahead and divide out this part, right? So we divide all that by parentheses 2 pi 2.5. All that equals h. Okay, go ahead and calculate the answer there. And calculate that. So when you do this on your calculator, you got to put all this top part in parentheses if you have a graphing calculator. Otherwise, it would just divide this part by that. So you put it, at the beginning, you put a parenthesis, plug in all this, in parenthesis, divided by parenthesis. Again, you got to put a parenthesis because otherwise it would just divide all this by 2 and then multiply it by this. So you put this in parentheses as well. Okay, the answer you should have gotten if you calculated it was 7.5 meters. 7.5 meters. Any questions on that? Okay. (12.3) Surface area of pyramids and cones. Okay, so we've got, here we have a pentagonal. It's pentagonal because the base is pentagon. It's got 5 sides, a pentagonal prism, right? So a vertex of a pyramid is the common vertex of the lateral faces of the pyramid. Here's the lateral faces. This point up here is the vertex of the pyramid. That's where all the lateral faces meet. So that's the vertex of the pyramid. The slant height of a regular pyramid is the height of a face of the regular pyramid. Okay, so the slant height would be in the middle of the, take the middle of this triangle to up to the vertex. That's the slant height. It's typically, we represent slant height with a cursive L. That's what slant height is usually. In a formula, you will see a cursive L for slant height. All right, everybody have that? Okay. The blue line there is the slant height of the pyramid. You can draw, if you know the height of the pyramid, like this distance, and maybe you know the apothem, then you can figure out the slant height through Pythagorean theorem. That's one thing you have to do sometimes with pentagonal prisms. So surface area. The surface area of the prism is the area of the base plus 1/2. It says SP. I think they're calling, when they say S, 1/2 S, this, they call it S. I would call it L, LP, because it's the slant height. Because it's a perimeter. You've got four triangles, right? So if you take the perimeter, that's all the bases, and then you multiply by the slant height, that's going to give you that area of the 4 triangles. It's just breaking it down. Another way you could do it is just calculate the area of this triangle, 16 times the slant height, get that, and then multiply times 4. It's the same thing, just the order in which you do it. Okay, so here we have a regular square pyramid, has a height. Okay, so when they talk about the height of the pyramid, they're talking about the vertical distance from the base to the top. They're not talking about the slant height. They're talking about this vertical distance. The height is 15 centimeters, and the base edge is 16. This is 16. Find the area of each lateral face. Okay, the area of each lateral face, okay, of the pyramid. So they're just wanting the triangles. Those are lateral faces. So it's going to be, here they show you, you take this blue triangle, right? We know the height. If this is 16, that's 8. So we use the height and this length 8. We do the Pythagorean theorem and we get L. Right? So you calculate L. When you calculate L, for L you get 17 when you do Pythagorean theorem. 8, 15, and 17 is a Pythagorean triple. All right, so they didn't show that part. I would put that in your notes so you knew how it was calculated. You did 8 squared plus 15 squared equals L squared. So L equals 17, right? So the area of each triangular face is 1/2 of the base, 1/2 of 16 times L. So the lateral faces 1/2 16 times 17 is 136. That's just one of the triangles. All right? It's just one of the triangles. Any questions? I'm going to go back. I want you guys, I don't like this formula here where they said 1/2 SP. Let's do, it's the area of the base times 1/2. Let's change that S to an L. The slant height, L, times the perimeter. One half L times the perimeter. All right. So now we have another example. Find the surface area of the pyramid. All right. It looks like we have all the information we need. We have the length of the side of each side of the hexagon. We've got the slant height, and we've got the apothem. Right? So let's plug into our formula. Surface area. Whoa. Where that came from. We've got surface area equals the area of the base, B, plus 1/2 L, P. Right? So we've got the area of the base is going to equal, in this case it's a hexagon, so it would be 1/2 ASN plus 1/2 L, and the perimeter is going to be the number of sides, 6 sides times the side length, so it's going to be S times N. So really, you know, there's kind of like 2 steps with the formula. You've got the general formula, then you got to plug into the situation we have. Like if this were just a square, the base were a square, you'd say S squared instead of 1/2 ASN, right? So, but anyways, we have a polygon, so we use 1/2 ASN, and then we plug in these different things for the perimeter and the slant height and so on. So it's going to be, all that is equal to 1/2. The apothem is 5 radical 3. The side length is 10, and the number of sides is 6. Everybody see where I got those numbers? The apothem of the hexagon is 5 radical 3. The side length of the hexagon is 10, and the number of sides is 6. Plus 1/2 L is 14. Times the side length is 10, times the number of sides is 6. So it's 1/2 L times 10 times 6. 1/2 is the, so you're doing you're really calculating a triangle. You've got 1/2, the base is 10 and the height is 14, and you've got 6 of those triangles, right? That's what's going on there. I want to make sure everybody understands the formula. If you understand it, then it's easy to remember what to do with it. Okay? Any questions? Everybody got it? Okay. So now, so the surface area you should have gotten was 679.81 feet squared. 679.81. Surface area of a cone. The surface area of a cone is, you've got the circular base, that's pi r squared. And then to do the side, you're going to do pi times the radius times, again, they use S. I think I like to use L for the slant height. S and L. Okay. They use S. I guess they call it S because it stands for slant height rather than L. Pi r squared times pi r L or pi r S. Let's look at an example. Surface area of a right cone. So we write the formula, surface area equals pi r squared plus pi r L, the slant height. So that's going to equal to pi times the radius is 6 squared plus pi times the radius is 6 times, okay, then the slant height, we need to find, we don't know what L is, it's this distance, okay, but I have that triangle, right, this is a right triangle, 6, 8, what would this be? It's a Pythagorean multiple. 6, 8, what would that have to be? All right. Well, if you don't know that by memory, you can do 6 squared plus 8 squared equals L squared. So that's going to be 36 plus 64 equals L squared, which is that is equals 100. So L equals 10, right? So pi times 6 times 10. So we get 36 pi plus 60 pi equals 96 pi m squared. All right, any questions there? I got it? So the answer would be B. Lateral area of the cone. So the lateral area would be what? What color would the lateral area be? It would just be what? Logan? Lateral area. Lateral means what? Side. So it's just the orange. You're not worried about the bottom. Just the orange part. So we have the traffic cone can be approximated by the right cone with a radius of 5.7 and a height of 18. So if we draw that in, we've got radius of 5.7, so that's 5.7, and a height of 18. There's your height of 18. What do I need to do to find, what do I need to know to find the area of the lateral face? Okay, so look back at your formula for cones. Which part of, there's two parts, which part represents the side? What formula would you use for just the side, area of the side? Will we use pi r squared or pi r L? The note says pi r s, but pi r L, which one would we use to find the lateral? What do you think, Kennedy?
Pi r L.
Yeah, we'd use the pi r L. So the slant height, okay, we've got to figure out L, right, to figure out this, L, we'd have 5.7 squared plus 18 squared equals L squared. So then we would square everything out, and we would calculate L. Let's calculate L. What's L going to be? Anybody calculate L? What'd you get, Aaron? 18.88? Sounds right. 18.88. So then we plug in, so it would be pi times the radius is 5.7, and the slant height is 18.88. We multiply all that out. And we get the answer, which should be 18 point. That's the slant height. Find the lateral area. So pi r L should have gotten 338.4. 338.4. Okay, any questions on that problem? Any questions in general about formulas and using this to solve for equation? All right. So we have, let's review. We've got, so that's it on the notes. We'll review the equations.